In a world where size often spells dominance, the tiny Danionella cerebrum swims proudly in the opposite direction, quite literally. Measuring barely 12 millimeters long, it's so small it could use a grain of rice as a beanbag chair. And yet, despite its humble proportions, this fish is quietly shaking up the world of neuroscience. Let's dive in the microscopic world of the Danionella cerebrum. Now, first things first. Don't confuse Danionella cerebrum with the so-called glassfish. They might both be transparent, but Danionella is in a league of its own. Native to freshwater streams in Myanmar, this miniature marvel belongs to the same family as the well-known zebrafish, yet it outshines its cousins in one remarkable way. It's see-through and brainy. Yes, you can actually watch its brain in action. No X-rays, no fancy scans. Just place it under a microscope, and you've got front-row seats to a live brain performance. So why are researchers practically doing backflips over this fish? Two reasons. First, its skull is translucent, which makes its brain entirely visible. Second, its brain is one of the smallest vertebrate brains, yet it shows complex activity. That means scientists can observe real-time brain function in a living vertebrate without invasive surgery. In neuroscience terms, that's like discovering the Rosetta Stone and realizing it glows in the dark. Imagine being able to track how a brain reacts to light, sound, or social interaction as it's happening. Thanks to this fish, researchers are mapping neural circuits the way old-school explorers once charted the open seas. And here's the kicker. It's not just transparent in the head. Much of its body is see-through too, giving it a ghostly sci-fi vibe that would make any special effects director proud. Let's talk skeletons, or rather, the lack of one. Danionella cerebrum has a lot of missing bones. In fact, that's part of what makes it so fascinating. While most vertebrates come with a standard-issue bony cranium, this fish skipped the full package. It has no bony skull roof, allowing light to pass through its head like a biological skylight. Evolution, it seems, made a trade: protection in exchange for visibility. It's the fish equivalent of living in a glass house, but having nothing to hide. Don't let its quiet demeanor fool you. Danionella cerebrum may be small, but it's got a surprisingly loud voice. For a fish, anyway. In a 2020 discovery, researchers found that males produce clicking sounds during courtship rituals, possibly to impress the ladies or challenge rivals. The mechanism? Vibrations in their swim bladders. Kind of like drumming on a balloon. It's one of the smallest vertebrates known to make noise. Nature, it seems, has a sense of humor. A fish the size of a fingernail, crooning like a lounge singer. Here's where things get wild. Because Danionella cerebrum shares many neurological similarities with other vertebrates, including humans, it offers an incredible model for understanding how our own brains work. Studying it could lead to breakthroughs in understanding autism, Alzheimer's, and how learning physically changes brain structure. All thanks to a fish you could lose in your drinking straw. And because it's genetically tractable, meaning scientists can alter its DNA easily, it's the perfect subject for experimental models. Want to know how a particular gene affects memory? Pop it into a Danionella? Want to track neuron firing patterns during learning? Just turn on the microscope. We've entered a new age of brain science, and this little glassy genius is leading the way. Who would have thought one of the most promising keys to unlocking the mysteries of the mind would come in such a tiny, almost invisible package? Danionella cerebrum is living proof that size isn't everything. And sometimes, the most mind-blowing discoveries come from creatures you could accidentally vacuum up. Now, it's time to see how much you've learned from today's episode. We've got 3 fun trivia questions coming up. Ready? Let's start. Question 1. What makes Danionella cerebrum such a valuable model for brain research? The correct answer is C. Its brain is visible without surgery. Thanks to its transparent skull, scientists can observe real-time brain activity without invasive techniques, making it ideal for neurological research. Let's try another question. Question 2. Where is Danionella cerebrum naturally found? The correct answer is C. Streams of Myanmar. This tiny fish calls the freshwater streams of Myanmar home, making its groundbreaking discovery even more regionally significant. Let's move on to the last question for this episode. Question 3. How do male Danionella cerebrum attract mates? The correct answer is C. By clicking using their swim bladder. Males produce courtship clicks by vibrating their swim bladders, a surprising vocal talent for such a small fish. Great job if you got all 3 questions correct. If you missed any, no worries. You're now officially smarter than you were 10 minutes ago. Keep exploring the wonderful, weird world of animals. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.